A public IP address makes a server reachable, but a real domain and HTTPS makes it usable as an actual web service. Right now, this Moodle site still lives at a temporary HTTP address based on the server IP. The browser cannot verify a meaningful identity for it, and the traffic is not encrypted. In this video, we will connect the domain to Apache, obtain a trusted certificate from Let's Encrypt, redirect normal HTTP visits to HTTPS, update Moodle's canonical address, and prove that renewal can happen automatically. Welcome back to Open Education Operations. Let's give this Moodle site its real address and its padlock. Before changing anything, I will place my domain, my VPS address, and certificate contact in the shell variables. This makes the commands easier to read and reduces the chance of mistyping the domain halfway through the configuration. The first variable holds Moodle's new public hostname. The second keeps the server's current public IPv4 address available for comparison. And the final variable holds the operational contact used during Certbot account registration. I will print all three values once before they are used in any configuration command. These variables exist only in the current terminal session. If you disconnect and open a new SSH session, define them again before continuing. With the values checked, we can verify that the domain really reaches this server before asking a certificate authority to validate it. A certificate does not make DNS correct. Let's Encrypt will resolve the hostname independently, so the domain has to point to this VPS before Certbot enters the picture. I will start with the DNS view available to the server itself. This asks Ubuntu's active resolver for the domain records. The E record should point to the VPS IPv4 address, just as we configured at the end of the previous video. Now I will check whether the server has a globally routable IPv6 address. This matters because a 4A record changes the validation path. When both E and 4E records exist, Let's Encrypt prefers IPv6 for its initial connection. An IPv4 only site does not need a 4A record. But if a 4A record exists, it must point to the correct server. A stale IPv6 record is one of those problems that makes DNS look correct at first glance, while certificate validation quietly goes somewhere else. Now I will switch to PowerShell on my workstation to get an independent view of the DNS records. Remember, my variables are not available here, so I will use the full domain name instead. And I will check for an IPv6 record separately. No 4A record is returned here, which is fine for an IPv4 only setup. The authority information only identifies the DNS zone. It does not mean that this hostname has an IPv6 record. So the Moodle domain is intentionally IPv4 only. Finally, I will make a simple HTTP request by hostname. The first line should show an HTTP response from the server. You may see a 200 or a redirect code such as 301, 302, or 303. At this stage, Moodle might still redirect toward the VPS IP because its own canonical URL has not changed yet. What matters here is that DNS resolves and Apache receives the request for the domain. This is the moment to stop and fix DNS if anything points elsewhere. Production certificate requests are not a good substitute for patient DNS troubleshooting. At the end of the previous video, we verified the server's public boundary. I won't repeat that full inspection here. We will check the listeners and firewall again at the end after HTTPS has been added. For now, I only need to confirm the two values that will change in this video. First, Apache's current hostname. Apache still identifies this virtual host using the VPS address. We will replace that temporary identity with the domain before Certbot examines the configuration. Now Moodle's current canonical address. Moodle is also still using the temporary HTTP address. One final pre-flight check: the server clock. TLS certificates have activation and expiry timestamps. If the server clock is badly wrong, a valid certificate can appear expired or not yet valid. The important lines are system clock synchronized yes and NTP service active. The two addresses are confirmed, and the clock is synchronized. Before changing either configuration file, I will create local recovery copies. This is a very important step. Small file level backups are always useful for comparison and emergency recovery. First, I will create a backup directory that only root can access. The install command creates the directory and applies mode 700 in one step, so regular users cannot browse its content. Now I will copy the Apache virtual host while preserving its ownership and permissions. And I will do the same for Moodle's configuration. The -A option preserves metadata, which makes these suitable restoration copies rather than simple text snapshots. I will confirm that both files are present without opening their content. With the recovery copies in place, Apache can stop identifying his site by its temporary IP and start identifying it by the domain. Certbot's Apache plugin needs to identify the virtual host that belongs to this hostname. So I will replace the existing server name value with the domain stored in our variable using this command. This is a targeted line substitution. It keeps any indentation, replaces the old value, and leaves the rest of the virtual host untouched. Now I will verify only the directive we just changed. Great, now our domain name is set as the server name instead of the server's IP address. Before applying any Apache change, we first test the complete configuration. A configuration test catches syntax problems before they can affect the running website. Now that our syntax is okay, I will apply the change with a reload rather than a restart. A reload asks Apache to reread its configuration without unnecessarily dropping the service. And I will inspect Apache's parsed virtual host map. This command is more authoritative than guessing from file names. It shows which virtual host Apache actually associates with each address, port, and hostname. Apache now recognizes the domain. The next piece is the certificate management tool itself. Certbot's official installation instructions recommend the snap package for most Linux systems. So that is the method I will use here. Let's begin by confirming that the snap support is available on this Ubuntu server. Standard Ubuntu server images commonly include snapd, but checking is better than assuming, as always. Certbot's official instructions recommend removing an older Certbot package installed through the operating system package manager before installing the snap version. So let's do it using this command. This prevents two Certbot installations from competing over the same command and renewal process. The command remains harmless when the apt package is not installed, so you can use it safely. Now I will install Certbot using the official snap package. The snap uses classic confinement because Certbot needs to work with Apache configuration and certificate files outside a tightly isolated application sandbox. And next, I will create the command link recommended in the official instructions. That makes the snap managed executable available through the normal Certbot command. I will verify which command the shell finds, and finally its installed version. Certbot is ready. Before it configures Apache for HTTPS, I will open exactly one additional public port. In this step, first I need to inspect Ubuntu's named firewall profile for secure Apache traffic. This profile covers HTTPS on TCP port 443 only. Port 80 is already open separately for normal HTTP redirection and also for Let's Encrypt HTTP 01 validation. Now I will allow the secure profile. And I will inspect the resulting rules. When IPv6 support is enabled in UFW, the corresponding rule appears as well. The important point here is to verify the actual firewall output rather than assuming that both address families were covered. For a brief moment, the firewall permits 443 before Apache is listening there. A firewall rule opens the path. It does not create the service. The next command fills that path immediately by configuring Apache for HTTPS, so let's do it. The domain resolves correctly, Apache knows which virtual host owns it, and the firewall is ready. Now Certbot can perform the real issuance. --Apache selects the Apache plugin for both validation and installation. Certbot temporarily configures the HTTP O1 challenge, proves control of the hostname through port 80, obtains the certificate, and deploys it into Apache. The -D option names the one hostname covered by this certificate. We do not need a wildcard or an extra www name because Moodle lives on one dedicated subdomain. --agree -term of service accept the SME subscriber agreement. And the --non-interactive tells Certbot to use the options provided in this command instead of pausing to ask questions. --redirect tells Certbot to redirect normal HTTP traffic for this authenticated virtual host to HTTPS after issuance succeeded. So this is very important. The email is supplied during Certbot account registration, but there is an important update here. Let's Encrypt ended certificate expiration reminder emails in June 2025. So an email address is not our renewal safety net. Automation, renewal testing, and monitoring are. Behind the scenes, Let's Encrypt sends Certbot a challenge token. Certbot makes that token available under the domain on port 80, and the certificate authority retrieves it to verify that the server controls the hostname. Once that proof succeeds, Certbot stores the certificate and private key under etc Let's Encrypt, configures Apache for port 443, and activates the HTTP to HTTPS redirect. On practical note, if you are rehearsing this process rather than requesting the real certificate, you need to add a --staging option to the command. This uses Let's Encrypt's testing environment, which helps you avoid production rate limits. But the certificate it installs is intentionally not trusted by browsers. And when you are ready for the real deployment, run the command from a clean state without --staging. So given that here I am using it for my production server, I will not use the --staging. Great, Certbot has successfully issued and deployed the certificate for our Moodle domain. Apache is now reconfigured for HTTPS, normal HTTP requests will be redirected securely, and Certbot has registered the certificate for automatic renewal. The certificate is public identity information. The private key is not, so never share the private key on screen. Before changing Moodle's own URL, let's verify that Apache accepted the new HTTPS configuration correctly. So first, I will validate the complete Apache configuration again. And now I will confirm that Apache is active using this command. And I will inspect the virtual host map with HTTPS included. Certbot commonly creates a separate SSL virtual host file, but the exact file name is an implementation detail. Instead of hard coding a file name, we can ask Apache which files and virtual host it is actually using. Next, I will list the enabled sites. You can see the original Moodle.conf remains responsible for HTTP and the redirect, while the new SSL virtual hosts handles HTTPS and points Apache to the certificate and private key files managed by Certbot. Now I will locate the certificate and redirect directives across the available site files. This command lets us inspect what Certbot changed without opening any private key content. Now let's ask Certbot which certificates it is managing. This displays the actual hostname, certificate paths, key type, and expiry date. You might have heard a lot about Let's Encrypt being a 90-day certificate service. That is still true for the default classic profile at the time of this recording. But the timeline is changing. The default is scheduled to move to 64 days in February 2027 and 45 days in February 2028. That is one reason good certificate management is built around automation rather than a calendar reminder. Certbot decides when renewal is due based on the certificate's real lifetime instead of assuming a fixed 30-day window. Finally, I need to confirm that Apache now owns port 443. The web server layer is ready. Now Moodle needs to stop generating links for the temporary IP and adopt the HTTPS domain as its permanent home. I will update only the www-root line in Moodle's configuration. www-root is Moodle's canonical address. It influences redirects, links in pages and email, and the URL Moodle expects users to visit. And of course, I need to verify the line is changed. Now I need to purge Moodle caches after changing the site URL. This command runs Moodle's own cache purge tool as the web server account. With an HTTPS www-root, Moodle can generate secure links consistently and apply the cookie behavior expected for an encrypted site. Now we can test the public behavior from a client's point of view. To achieve this, I will check the HTTP response and its redirect location. The grep part keeps the display focused on the status and destination instead of printing every response header. The response redirects to the HTTPS version of the same domain. So HTTP to HTTPS redirect is working. Now I will request the HTTPS site normally with certificate verification enabled. And next I will inspect the certificate exactly as TLS client receives it using this command. The -servername option sends the domain through TLS servername indication, or what we called SNA. That lets Apache choose the correct certificate before the encrypted HTTP request begins. The subject identifies our Moodle domain. The issuer is Let's Encrypt, and the dates show the certificate's current validity period. I will also check the old bare IP address over plain HTTP. This is an observation rather than a certificate promise. Apache selects name-based virtual host using the requested host name. And a request made directly to an IP might fall through the first applicable virtual host. From this point forward, the HTTPS domain is Moodle's supported address. So accessing the site through HTTPS and the IP address is not equivalent, because the certificate was issued for the hostname, not the IP address. Now let's check if all this works. Let's open the site in the browser. Great! Now Moodle site loads over HTTPS. Let's open the browser's connection information and verify that the certificate is trusted and issued for the correct domain. Here, the padlock is the visible payoff. But it is not the end of the job. A certificate that works today still needs to renew without someone remembering to type a command mount later. So let's inspect the Certbot systemd timer installed by the snap package. The timer runs renewal checks periodically. Now let's simulate a renewal through Let's Encrypt staging environment. Now that Certbot has created a certificate lineage and stored the renewal settings, we can test the future renewal process safely with --dry run. Certbot does not rely on a fixed 30 days before expiry rule. Remember this. For certificates longer than 10 days, renewal is normally considered due when less than 1/3 of the certificate's lifetime remains. That lifetime-aware behavior becomes even more important as public certificate lifetimes get shorter. A successful dry run proves much more than a presence of a timer. It confirms that DNS still resolves, port 80 remains reachable, Apache can answer the HTTP 01 challenge, and Certbot's stored renewal configuration works. Because this setup uses HTTP 01 validation, port 80 remains open for future renewals. Visitors are still redirected to HTTPS, but the certificate validation path stays available. We have done a lot in this video, but still, we need to do verifications and prove the public-private boundary still holds. HTTPS should add one public web port, not turn private tools into public services. Let's filter the listener list to the ports used throughout this series. Apache now serves HTTP and HTTPS. MariaDB remains local on port 3301, and Mailpet remains local on ports 1025 and 8025. Now let's check the firewall view. The intended public surface is SSH, HTTP, and HTTPS. Nothing was opened for the database or Mailpet. Now I will verify from my Windows workstation. Let's start by the verification for HTTPS using the port 443. And I will test the Mailpet web ports directly through the public hostname. The first service belongs on the internet. The second one does not. And the result proved that. Adding a domain and a certificate changed the public web layer without weakening the private service boundary we built in the previous videos. Now, we all like to see an HTTPS protected domain. But Moodle also needs to behave correctly after its canonical URL changes. I will log in through the HTTPS domain and open the administrator dashboard. I will also open the browser developer console and check for mixed content warnings. The console shows no mixed content warnings, so this page is not loading any visible resources through plain HTTP. Mixed content happens when an HTTPS page still tries to load an image, script, style sheet, or embedded resource through plain HTTP. On a new site, there may be nothing to fix. On an older site, hard-coded course content or theme settings are common places to look. Moodle includes tools for replacing old URLs, but bulk database replacement should never be performed casually or without a database backup. Because this is a new installation, we only need to check that no mixed content warnings are present. On an established site with older embedded links, take a database backup before using any bulk URL replacement tool. Now time for another test. I will need to test a one user-facing link through Mailpet. Because Mailpet web interface remains loopback only, I will need to reopen the SSH tunnel from PowerShell using this command. Then I will open the local tunnel address in my browser. Next, I will trigger password recovery for the test student and inspect the captured message. The receipt link now begins with the HTTPS domain. This is application level proof that Moodle has adopted its new canonical address, not merely that Apache has a certificate. Finally, let's run Moodle cron once from the terminal. Cron itself is a local command line process. It does not run over HTTPS. What matters is that it still completes normally and that any URLs Moodle generates now use the HTTPS domain. At this point, the domain, web server, certificate, application URL, renewal path, and private service boundary all agree with one another. This is good news for us. So let's recap what changed. The DNS record already pointed the Moodle hostname to this VPS. We changed Apache's virtual host from the temporary IP to that domain, installed Certbot from its official snap package, and opened HTTPS only when the service was ready to use it. Certbot proved control of the hostname through port 80, obtained a Trustless Encrypt certificate, configured Apache for port 443, and redirected normal HTTP visits to HTTPS. Then we updated Moodle's WW root, purged its caches, verified the certificates from a client, tested automatic renewal, and confirmed that password reset links now use the secure domain. And just as importantly, MariaDB and Mailpet stayed private. HTTPS expanded the website, not the server's entire attack surface. We are leaving HSTS and broader security headers for the next hardening stage. HTTPS tells browser to refuse HTTP for a defined period. It should be enabled only after HTTPS has been tested and proven stable. Our Moodle site now has a real public identity, encrypted traffic, and a tested renewal path. Thanks for watching, and I will see you in the next Open Education Operations video.